All right, here we go. All right, so here is our projectile motion problem. Okay, so we were talking about projectiles fired from a cliff 500 feet above the water at an inclination of 45 degrees to the horizontal with a muzzle velocity of 400 feet per second. In physics, this is established by this equation. So they give you this equation. It's a quadratic equation because you got an x squared, an x, and then a constant. So this whole fraction here is like A. This is, B is 1 and C is 500 out of that. So that's what they've given you, this equation. You don't have to come up with that on your own. And x is the horizontal distance. Y is your distance projectile from the height of the projectile away from the ground. Okay, so maximum height. Anytime you see maximum or minimum, what are we looking for? Vertex. So how do we find vertex? Axis of symmetry, and then plug it back in. Okay, so that's what we're doing here. So negative b would be -1 over 2 times a, and a is that ugly fraction there. And then do that work. We end up with the x value being at 2,500. That 2,500 represents what? That's not the maximum height. It's the x, which x is what? Horizontal distance away from the cliff. So what we're seeing here is this projectile is gone 2,500 feet away from where we shot it from in this distance. The equation, when we plug this back in for x in the equation, we're going to get how high the thing is at 2,500 feet. That's what we're finding, okay, out of that. Okay. So here is plugging it back in and got 2,500 plugged in for x and work that out. Obviously, you can use a calculator to do that. I don't expect you to do this on my hand. Just showing all those steps. 1,750 feet. So our maximum height is 1,750 feet above the ground. It's happening at 2,500 feet away from where we shot it. And so imagine the cannon is here and the clown flying toward the, well, in this case, the ocean is 1,750 feet above the water and then 2,500 feet away from us, from where we shot from. Okay. B part, same equation, same everything going on there. How far from the base of the cliff would the projectile strike the water? So where's it at when it hits the water? What's the height when something hits the water? Say it again. 0. Okay, so what are we going to do with that equation? No. For y. 0 goes, so it's basically setting the equation equal to 0. So here's the equation. Instead of h of x, we're going to put it equal to 0 and solve it. What would be maybe the best way to solve that? Is it factoring? No, definitely not. Anytime you got a fraction in there, factoring's not going to be a good option. Quadratic formula or quadratic equation. There it is. Negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. How many answers are you going to get from that? 2. They're negative 458 and positive 5,458. Huh. What does that even mean? No. It will be on these two, but which one is the right one to pick? Why not the negative one?
Because that negative would be on way.
Well, I mean, no negative, that's exactly it. No negative distances, right? Then the negative here implies that the shot went backwards from where we started. And we know that's not what happened. We know it went out to the water. So 5,458 is where we go from there. Solution cannot be negative, so the projectile hit the water at that distance from the base of the cliff. the height at that distance is 0. So here's a graph of that. You could graph this equation with your graphing calculator. You'd have to set your window kind of weird, pretty big, X and Y values to get it to show you this. But you could graph that, and if you use Zoom Fit, which I think is Zoom 0, it'll open, it'll set your window to where it'll show you this, but then you got to look for the numbers out of that. But you can see that picture. This is what it looks like. You shoot the cannonball, and it follows that path. We're eliminating any kind of wind or other factors that a physics class would incorporate into this, that you would have a lot of other variables. But we're just saying, okay, in a perfect world, this projectile goes that way. Okay. All right. So on the graph, our X values from 0, our distance away from the cliff from 0 to 5,500, and then the maximum, we can use the maximum to find the height of the projectile. The 0 is the distance. Okay, so the idea here is anytime you need to find the maximum, you're finding that vertex. Anytime you find distance away from the origination point, you're looking at zeros of the polynomial, or of the quadratic in our case. Let's look at this one. This is one of the tougher problems here, the Golden Gate Bridge problem, or any suspension bridge problem. Okay, we're simplifying suspension bridges, and we're making the, y'all know what a suspension bridge is, right? There's a picture of one right there. Got these big cables here, really large cable with smaller cables connected to it, and it holds up the weight of the road there. Awesome feat of engineering to decide to do it that way. Really, really cool. All right, so suspension bridge spans the entrance of the San Francisco Bay. It's 746 feet tall, and towers are 4,200 feet apart. The bridge is suspended from 2 huge cables, more than 3 feet in diameter, and the 90-foot roadway is 220 feet above the water. The cables are parabolic in shape, so we're kind of simplifying that a little bit. And they touch the road surface at the center of the bridge. Find the height of the cable at the distance of 1,000 feet. Okay, so what we've done and what they're doing here is they're trying to simplify the problem, and they're setting up the bridge so that the numbers become easy. By putting the vertex at 0, 0, that's where the large cable comes in contact with the road. It's right there at the edge, top of the road. And then, so we put that at 0, 0. That makes it easy to split our 4,200 feet apart into 2,100 on each side. Because it's parabola, it's symmetric, right? Okay, come on in. So if it's symmetric, then you got the same distance on each side. And then we know that the towers are 746 feet tall, and they're 220 feet above the water. So here's the water, and this distance here from the edge of the water up to the surface of the roadway is 220. So that's why the Y values are 526 there instead of 746, because we got our distance from the water to the top of the road. Okay, so this is where they're getting all these numbers. That total distance is 746, which is from our problem right there. But that Y value right there is important. Okay, now we want to find the height of the cable at a distance of 1,000 feet from the center. So with this problem, we've got some information about the quadratic. We just don't have the equation to just plug 1,000 in. How could we get that equation? Or what could we do to get there? What could we do to get there? Well, we know it's quadratic, right? Because they said it's parabolic in shape. That tells us it's quadratic. So a quadratic looks like that. If the vertex is 0, 0, we're simplifying the problem so that we've got an easy equation to find. If the vertex is at 0, 0, then it's something times x squared. No bx, no c. Because c is 0. B being 0 also sets that vertex at 0, 0. Okay. Now, what we can do then is take one of the ordered pairs. We've chosen to use the one with positive x and y values just because it's positive and you don't have to deal with negative signs. The y value is 526. The x value is 2100. If we solve this for a, we'll have the exact equation of the parabola that we've drawn here with this cable. Okay, so taking an ordered pair and plugging it in for x and y, and then that'll give us a once we solve it. So we divide by 2100 squared. That's a big number. You can do that, that with the calculator there. So this is the equation. So instead of writing out that big long decimal there, we just left it that fraction. Understand that it's a big long decimal there. Okay, that's a. That's our equation. Once you have the equation, if we need a height at a certain distance, what are we? Our certain distance is 1,000 feet. What do we do with that 1,000? Plug it in for what? X, because this 1,000 in our picture here is the x distance. So if we plug 1,000 in for x, we can work that out and get how far that is away from where the cable meets the road. Okay, so plugging 1,000 in here, working all this out, big ugly decimal, remember, and we're going to round it to the nearest tenth of a foot. 119.3 feet is what that ends up being. And all this stuff, calculator do, that sort of thing. Really, really not a hard problem. It sounds incredibly difficult, but you're simplifying it by setting that vertex at 0, 0. And that's kind of a strategy you want to go about when you see one of these problems with a bridge. Okay. All right. Building quadratics. Quadratic, when we're doing linear relationships, we have some scatter plots, and we look for it to be, kind of jumble up toward making a line. It trends toward a straight line. These trend toward parabolic shapes, right? Because this kind of looks, like a parabola. This kind of looks like a parabola with a negative leading coefficient, right? That's what that looks like. So that's what we're looking for when we make a scatter plot. It's something that looks like that. You don't want something that looks like a straight line because that's linear. So we're looking for things that look like a parabola. So if we had some data, and you've got that whole table there on your sheet there, what are we going to do with the fertilizer and the yield? Where are we going to put that if we want to find a regression line to get a scatter plot? We need to decide if it's correct. Do what now? And where do we put our x and y values? How? How? How on our calculator? Stat edit. This is the x list. The fertilizer is going to be your x list. The yield is going to be your y list. So list 1 is the fertilizer. List 2 is the yield. Okay. Hey.
Is this a new paper?
They wrote it on the edge.
Okay. There's
That
a
okay?
new one.
Thanks very much.
I'm sorry.
That's right. Okay. Thank you. All right. So, why is that so small? There we go. Hit stat, edit, and I already had that typed in, so y'all wouldn't have to wait on me. So there's my list 1 and my list 2 of that on the calculator. So this is actually the easy part of this lesson, is getting it to make the equations. So get your data in there. 40. Hang on.
Is this internet thing changed? Like, when I was supposed to start my computer, he said I go to that, and I went to that, and then he said connect on that. I'm trying to show you so you can video and already show you.
It shouldn't have changed.
Okay, there's no that, there's not that on my thing anymore, so I don't know why. Okay, never mind. Go ahead and change it. That's all right. That's what I was wondering.
Is your projector on?
Yeah.
Is it on network?
But I checked the network
Give me like 10 minutes and I'll come check it. All right. All right, let's finish up here. All right, so we got those lists typed in.
I can't read on the paper.
Okay. All right, so I'll scroll down so you can see. Press the down button a few too many times. All right, so 25-20, and the next one is 25-21, 30-30, 35-35, 40-40. So the X values are getting two of the same, and their increments are by fives. And then the Y values that go with them are there, so you can see a bit better there. All right. Once you get all those typed in, you're going to make a scatter plot just to verify that this is quadratic in nature. How do we get it to do a scatter plot? Second, y equals. Turn split stat plot 1 on. And our type should be the scatter, the first choice. X list be L1, Y list L2. Okay. And then I'm gonna hit graph. And then I'm gonna hit, I got an equation I gotta get rid of and get rid of that so we don't confuse us there. 40-19 are both of the last ones. 40-19 and 40-19. All right, so hit graph, and then how do I get it to zoom to the stats? Zoom 9 for zoom stat. Does that look quadratic? Yes. Gabby, you got a question? All right, so you got a problem with your list. Yeah. You got something off on your list. Your list is not right. You don't have the stat block turned on. Second y equals. Turn that on. Then. You gotta have your stat plot turned on before the zoom 9 will even do it. Won't help you. All right, so just getting that list typed in correctly is a big thing, and then getting it to make the scatter plot and verifying that it's quadratic. Okay, it's quadratic, looks like a parabola. You know, it's got that shape to it. What we want to do is get the calculator to give us the equation of that quadratic. You go to the same place you went to get the line of the best fit line. So where do we go for that? Stat, calculate, and we're instead of doing linear regression, which was 4, we want to do quadratic regression, which is 5. List 1, list 2, that all should be defaulted, shouldn't be any different for that. And then hit enter. And it gives you a standard form of a quadratic and then tells you what A, B, and C are. Okay? Gives you the equation of the quadratic. We're going to round to 4 decimal places. Yes, sir. Yours didn't work. Let's see what. You got your stuff in this form this time. All right, so what you've got to do is you would have to go back and re-enter that list and this one, and then it's. All right. So we're going to round to 4 decimal places on this stuff. Okay. So that'd be 0.0171, and then 1.0765, 3.8939. That 9 will stay the same. Okay. Rounding 4 decimal places. That gets us that equation. If we've got the equation, then we can find anything we need. We can find the distance or the value at, let's screw that up, second entry. Put that back up there so you can see it. So we've got the A, B, and the C. We've got the quadratic equation. We can then use that to find anything we need out of the problem, okay? So if I went back here, I find that equation. That's what we've done. Those numbers there, if you put everything in the right way, we can then use that function that we found to determine the optimal amount of fertilizer to apply. What's optimal? Is that another word for best? Best would be what word goes with optimal? If you optimize something, it's the same as finding the maximum. Okay. Look, remember our parabola, the data was a parabola that did this. So optimal would be where's our highest yield out of that. So what do we find to find the highest yield? The maximum. So we find the vertex. Okay. We could graph that equation if you wanted to and use it. That's what I'm gonna do. I'm gonna show you how to do that. So I'm gonna graph this equation. So in y equals, I'm going to type in the equation with the rounded values. So I got a negative 0.0171 x squared. Again. Plus 1.0765 x plus 3.8939. Hit graph. Remember, I've got that scatter plot already drawn there. So there I see my parabola that I've made going through my data. And it looks like it fits pretty good. It's kind of right in the middle of all of them. Okay. What I want to do is find the maximum. We know it should be around there. Your calculator will actually help you find that if you got the graph. The way to do that is to hit second trace. We want to find the maximum, right? Because we're dealing with a parabola that opens down. So that's option 4. It's going to ask you for a left bound. Make sure you're to the left of where the maximum's at. I'm going to get a little closer. Okay? Yes, ma'am. Second trace. Second trace. You're not getting trace. Maximum. All right, so I'm going to make sure I'm to the left of that. So a little more to the left of that. Just make sure you're to the left of it. And then hit enter. And then the right bound, make sure you're to the right of where the maximum would be. You can see that in your graph. That is definitely to the right. Okay. Hit enter. And then it asks you to guess. Do that. Actually move your cursor to where you think the maximum is. I think it's close to right there. And here it finds, thank you, right. The maximum is at a fertilizer amount of 31.2135 and a yield amount of 20.8. 0.5541. You round to 4 decimal places. We find that maximum. That finds us the vertex. How else could you do that? You got close. You're okay. Yeah, you should be very, very close to that. I'm not going to be just, it has to be exactly on it, but it should be very close to that. I think your guess could have made some way that it calculated it. Okay. You could also do negative b over 2a and then plug that answer into the equation and get your maximum values out of that. Okay. So scatter plot, this is the parabola of best fit is what it's finding here, the quadratic of best fit. Instead of line of best fit, we're doing a quadratic of best fit. And then using that to either maximize or minimize or find where, what are the places where it doesn't help any. Okay. So here, putting this amount of fertilizer yields 20 and a half, almost 21 bushels, which is the maximum there. And actually math that farmers are using these days. My wife has a cousin who worked for a company for a while that was their job. They would take calculations of your fields and they would take soil samples. They did a lot of math with it, but basically they would find what's the best thing to do to increase the yield of your field. And there was a certain amount, and it was dramatic to go to the fields that he was in charge of, or the company he worked for was in charge of, and see the difference in a field that was untreated and then, or treated like everybody's always done it, and then one that was treated with the optimized methods. It was just unreal. Like corn be like this, that kind of difference in the yields is unreal. So ag business uses this sort of thing. A few more variables involved, but basic idea is that same stuff. All right. So with this on page, this is what the practice problems you need to look at for the rest of till about 9 o'clock today and tomorrow. Page 312. Numbers 3 through 31. Okay. Start with the odds. If you have trouble with some of those, go to the even ones that are similar to it beside that. But that'll get you what you need